When working with percents of a field, you'll need to clearly identify the inside and outside rectangles. Be careful with percents. What this means is you'll need to recognize whether the percentage is related to the small rectangle, the big rectangle, or the frame. Let's look at example 1, where a man is mowing his 40-foot by 50-foot rectangular lawn in a spiral pattern starting from the outside edge. This means he has a strip of mowed lawn that is of uniform width all the way around the outside of his field. 90% is mowed by noon, so that leaves 10% of the field unmowed. To find the total area, we multiply length times width. This gives us a total area, we'll call it A sub t, of 2,000 square feet. To find the little piece that's left unmowed, we can multiply the area total to find the small piece by multiplying 2,000 times the 10%, or 0.1. This area for the small unmowed part is equal to 200 square feet. Now we can write an expression for the decrease in of the unmowed rectangle. Length times width equals area, just like always, but now we can express that decrease in unmowed portion of the field by taking the original length 40 and subtracting 2x from it, this x here and this x here. Likewise with the width, we can take 50 and subtract this x and this x from it to represent the leftover unmowed piece of 200 square feet. From here, foiling, we're going to get 2,000 minus 80x minus 100x plus 4x squared is equal to 200. Setting my equation equal to 0 means I need to subtract 200 from both sides. This gives me 1,800 minus 180x plus 4x squared is equal to 0. From here, I can divide everything by 4. This gives me 450 minus 45x plus x squared is equal to 0. Rewriting with order of descending exponents will make it easier to factor. When we factor it and set the factors equal to 0, we get x minus 15 and x minus 30 as my binomial factors. Setting those equal to 0 gives me two solutions, x is equal to 15 and x is equal to 30. 30 will not make sense in the original equation, so we throw that one out because it would create negative distances, but we keep x equal to 15. So the piece or strip that was mowed was 15 feet by noon. In example 2, we have a woman that has a 50-foot by 25-foot rectangular field that she wants to increase by 68%. So the original area was equal to 50 times 25, which was equal to 1,250. If we want to find the increase of this outer uniform strip, we will have to find out what 68% of 1,250 is to get the area total for the new field. This will be 1,250 plus that new 68%, which will be 1,250 times 68%. This gives us a total area for the entire new cultivated field of 1,250 plus 850 square feet, or total 2,100 square feet. Now we can write an expression for the increase. The increase in length was 50 plus 2x. Notice that we're increasing instead of decreasing now. And the width was 25 plus 2x. This is equal to the new total area of 2,100 square feet. Foiling this out, we get 1,250 plus 100x plus 50x plus 4x squared is equal to 2,100. Subtracting 2,100 from both sides will give me an equation set equal to 0. And I'll combine my like terms in the same step. This will give me negative 850 plus 150x plus 4x squared equal to 0. I can divide everything by 2 to simplify my equation a little bit before I factor it. And this gives me negative 450, try that again, negative 425 plus 75x plus 2x squared is equal to 0. Rewriting in order of descending exponents, gives me something that's easier to factor. This is not going to be easy to factor using just regular old factoring tricks. So we're going to use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. This gives me x equal to negative 75 plus or minus 95 over 4. So x will equal negative 75 plus 95 over 4, or negative 75 minus 95 over 4. Notice that when I do this, this will be a negative value, and I don't want negative distance. So my answer will have to be x is equal to negative 75 plus 95 over 4, which simplifies to just plain old 5. This makes sense when we put it back into our original field equation, and it also makes sense to have a uniform border increased by 5 all the way around.